Hello and welcome to the Value of Testing podcast. My name is Randy Rice. I'll be your host today. And the topic today is about passing tests that prove nothing. And if you've been like I have been in those situations where you might have a great library of tests and you sometimes just wonder, what are we missing here? What are we not seeing? What's getting lost in the mix? It kind of reminds me too of building dashboards and how you measure things and the things that you show on a dashboard. And one of those things many times will be the number of tests that have passed versus failed. And too many times we fall into the trap of thinking that when we have a lot of green, things are good. In fact, there's an old joke about watermelon projects that are green on the outside, red on the inside. As my friend Greg Pascal calls it, it's the go for green syndrome, where you especially see this with test automation, where you want to see as many of your tests pass as possible, because in that context, a failure means that you have to go back and you have to see what caused this test to fail, and many times it's just a changed locator or something like that. But it can really kind of cause some problems for a test to fail in automation, because then, let's say you set it to run overnight and you come back the next morning to see your test results and you discover that the test run ran about 1 minute before it all failed. Well, one of the things that I think we're seeing now is that we're in a new world with AI, where AI can now generate a lot of impressive quantities of tests. But the question is, are they really good tests? Or are they merely executable tests that passed? Now, in the fairly recent past, many people didn't use test design generation tools or test case generation tools simply because they didn't have access to them. They either cost too much or they involved too much work. It's kind of like the model-based testing tools. You had to have a model that was in a format that the tool could recognize. Now, there are some combinatorial testing tools, kind of like ACTS, that are from NIST, that are kind of cool. They will allow you to set up conditions and things like that, and will generate like pairwise tests and things like that. And that was free, but not many people actually use that tool. So AI has now opened up the possibility now for everybody to have a test case generation tool. And that's kind of a new thing. Now, these tools are huge time savers, and I'm a big fan of test case generation tools. But I think we also have to understand and realize that they also have risk. Now, I recently came across a recent study. It's a very formal paper. It's peer-reviewed and everything like that. Very scholarly work. A lot of good science behind it. I haven't read the entire paper, mainly because research papers can get kind of dense, but I have had a chance to look at it long enough to really see some interesting things, and that's what I kind of want to pass along today. So this recent study examined more than 200,000 test artifacts, okay, and they found that AI-generated tests did well at identifying boundaries and null conditions and things like that, but had a greater potential for flakiness and slightly weaker assertions than human-written tests had. And that really brings out a really strong point here, that test generation is not the same as test design. Now, by the way, if you want to see the link and read that paper for yourself, it's available. It's not behind a paywall or anything. I'll have the link in the description of this podcast. So, anyway, the findings of this research they suggest that while AI agents may excel at rigorous boundary testing and those kind of techniques, they lack what it calls the environmental awareness needed to write stable, hermetic tests. Now, what is a hermetic test? I think about the old Johnny Carson joke about the things that are kept in a hermetically sealed jar on the porch of Funk and Wagnalls. And if you're not old enough to get that joke, don't worry about it. But hermetically sealed is kind of the idea here, that when something is hermetically sealed, it is totally insulated from the outside. So think about that applied to testing. A hermetic test is a type of software testing that is completely isolated from any external dependencies like networks or databases. Is something that you would often find, let's say, for example, in doing security testing. And it ensures that the test environment is self-contained and it's also reproducible. This is one of the things that I was really talking about in a past podcast about, can we really fully test agentic AI? Because so many people, when they think about agentic AI, it is an army of agents, for example, that are running out there in the real world in production, and you're not really testing when you're in production. You're monitoring at that point. But that's not what we're talking about here. We're talking about a self-contained and reproducible environment, the kind of environments that we've seen in the past. So this kind of study was rather controlled in its nature. And the advantage of that approach to testing is that if you do see a failure in testing, you can isolate that failure. You can determine, is it due to a defect in the code, or is it due to some kind of environmental, external kind of factors. Now, here are a few things I just kind of want to explore with you for a few minutes. This is going to be kind of a shorter podcast today, but I just kind of want to go over a few, I think, implications that this study brings out, at least in my mind. First of all, when we see a passing test, it only proves that its particular assertion passed. What I mean by that is, in any test that you create, you're going to have a condition with probably an expected result. And that's kind of like an assertion. When that assertion becomes true, then we see the test passed. One example of this is test-driven development. And in test-driven development, the tests that are there are more like assertions. And it's when this thing is happening, when this thing can be shown as true, then we have a pass in our code, and we have successfully implemented the code for that particular test. And when you get enough of those together, then you have a complete function that you've created. One of my early criticisms of test-driven development, of TDD, is that the tests were just too weak, as people normally applied it, at least early on. And in fact, there's no rule that that's still any different today, that test-driven development is only as good as the tests that you give it. Weak tests are going to equal weak code. Now, getting back to that dashboard concept that I was talking about earlier, when you show those pass and fail indicators on your dashboards, the eventual passes are what you're really after. I mean, someone might look at a pass percentage of 90% and say, hey, that's pretty good. 90% of our tests passed. And another might look at it and say, no, that's really bad. 10% of our tests failed. Well, what we're trying to see here is that is an ever-moving number. And in a dashboard, it keeps moving, or it should keep moving at least, up until you get to the release point. And it should almost reach 100%. And for those that don't pass, then there should be some kind of explanation around those. But where you really fall into danger is when it hits 100% and you think everything's great, but it's not. Because the truth of the matter is that tests can execute successfully while they check very little. It all depends on how the tests were written. If you just have a library of tests that just test a little function, a little function, a little function here, those really are pretty low value tests. And yes, they can show a pass, and yes, they may form some regression tests. but they become easy tests as opposed to challenging ones. And that once again falls into this go for green syndrome. And it also kind of validates something that I hear a lot from test managers that kind of get frustrated when their testers tend to want to stay on the happy path and test all the easy stuff. I did kind of an interesting experiment, by the way. Just 2 or 3 days ago, I was thinking about the classic triangle exercise. And if you're not aware of that, it's an exercise that Glenford Myers wrote about in his book on the art of software testing, the first book on software testing. Little book, but really great. And the problem here that he's posing to the reader is that, let's say that you're given an application to draw a triangle, and you're given 3 points of input, each representing the length of a side of that triangle. And it can draw an equilateral, a scalene, or an isosceles triangle, or maybe indicate invalid, depending upon the numbers that you provide to the input. And so based with just that information alone, how many test cases can you find? Now, I personally like to use that as a little mini assessment that I give to testers sometimes. And some testers, they'll just be solely on the happy path. And they might come up with maybe like 4 or 5 test cases there. They'll try to create an equilateral triangle, an isosceles, a scalene, and an invalid one. Other testers, they will push more of the limits, and they'll come up with maybe like a dozen or so inputs. But the really devious testers, they'll come up with like 30 or 40 inputs, like blanks, negatives, special characters, all things like that. So I posed this to ChatGPT, and ChatGPT did a really great job of fleshing out a lot of tests that you could apply for the triangle exercise. I was pretty impressed by that, but at the same time, I had to realize that there's probably some limitations. Probably even in that real simple exercise, some things that were probably missed there. Now, here's the thing, too, about weak tests. They create this illusion of confidence. It's false confidence in test, but it's also false confidence in the AI that we're using to create them. Now, my friend Greg Pascal that I referenced to about the Go for Green syndrome, we did a podcast episode fairly recently about his finding of what he calls the horseshoe effect. And what that is all about is that he was applying boundary value testing using AI, and it was doing great at doing testing around the boundaries, but what he found was that there were actually defects that fell within the boundaries, kind of like in the middle. That's where the highest concentration were. And so these defects may cluster not only at the boundaries, but also someplace in the middle of a range. Now, if you want more information, I'll also link that podcast there in the description. But there's some ways this could happen, like maybe the developers consciously protect the obvious boundaries, but they overlook things like transitions and interactions, maybe special calculations, or maybe unexpected conditions that happen deeper within the range. And if your code is being generated by AI, that could especially be the case. Now, your test suite, that might cover the minimum and maximum values, but once again, still miss the defects that might be squarely sitting in the middle. Now, traditionally, we've always said we don't have time to test all the values in a range. Well, with AI, we kind of have that possibility now that we're not quite as limited as we were before, and combining that with automation, now we kind of do have that possibility to test within every value within 2 boundaries. Another thing to think about here is that when you have a large test suite, which, by the way, I typically am not impressed when people tell me that they have like 10,000 test cases in their test suite, but because I'm thinking about maintenance. I have a Randyism that test cases are like kids. Every one you have is one more you have to keep up with, one more you have to maintain, one more you have to feed, send to school, all that. Same thing with test cases. And when you have this large test suite, things tend to get lost in the test suite. You can lose your idea of how much coverage, for example, you're getting with meaningful risk. Because there's so many test cases, it's really hard to know which features and which risk have been missed. Yeah, you have a test management tool, let's say, and it's showing you coverage levels of certain things. But many times you're missing the depth of coverage. That's something that very few people measure when it comes to testing. Yeah, they can tell you we cover 100% of the requirements, but that might be deceptive too. It might be like one test case per requirement, which is pretty thin. So you don't really understand the depth there of the testing. Now, also, one of the things to think about too is that AI can generate all kinds of variations of things to test, but it may totally miss what truly matters to your customers. That's where your human judgment and your experience comes into play, because it's the human testers that will contribute judgment, context, skepticism, and risk awareness into the picture. And it's also why good test design is about much more than just simply applying a technique at a surface level. Whenever I teach test techniques, which I do quite often, and I teach like the big four, the equivalence partitioning techniques and boundary value and decision tables and state transition, those are all great techniques. But you have to understand that there's a lot of nuance around those techniques that you really have to be aware of how you're applying them. Yeah, they're great if you're applying them in the right way. Now, there's one other thing that I want to bring up too, and that is about the metrics that matter here. I did a podcast not too long ago on meaningless metrics, but one metric that I think is helpful is not how many tests do we have, but it's rather what important things have we learned from our test. Now, that may be rather hard to measure. That may be more of a subjective kind of metric and more of a qualitative kind of thing. But the main thing about your test is that it should be providing information and learning and not just checking off a box or something. So you should be asking for every test that you have, every test case or every test script, what value is that bringing into the mix? What is it buying us? And if you can't answer that question of the value that it's bringing, that's probably something that you really need to think about dropping from your library. And I say that with a lot of caution because, I'm one of those testers that, I kind of like to go the extra mile in testing, and I want to make sure I'm not missing anything, but there's a point at which that can actually become a risk, and that's where you over-test and you're taking too much time with tests that just don't add value. So the thing I'm going to leave you with here is that your testing techniques, they can guide your test design, but they should never replace your own curiosity, observation, and judgment. And just testing the so-called correct textbook techniques and values doesn't automatically produce meaningful coverage. That's exactly how a green test suite can create false confidence. So I hope this has been helpful to you, thinking about these tests, especially when you get that sense that everything's looking good, but I'm not quite sure that it really is good. So anyway, check out the description for the links that I mentioned. Subscribe if you really found this content valuable. I appreciate any thumbs up, any comments that you might have on this. I'd love to hear your comments, as well as sharing this with people that you think also might need to hear this. Thanks a lot, and I'll see you next time.